All right, now let us start. So I'm the presenter of the webinar. I'm Gaurav Dare, and I have a bachelor's in engineering. I've done bachelor in engineering in computer science, and I'm a Red Hat certified system administrator. And currently, I work as a cloud architect and a DevOps engineer. So I have pretty much good experience in deploying the cloud infrastructure. Plus, I have experience in uh, building CI/CD pipelines, all the stuff which we do in DevOps. So this is today's agenda, where we are going to talk about what is DevOps, DevOps adoption, DevOps tools, and we are going to see what is CI/CD. Okay, anyone would like to tell me something about DevOps? Anyone has some idea about what is DevOps? Okay, so what is DevOps? DevOps is basically collaboration of developers and operational teams. Earlier, developer used to write the code and operational team used to deploy the code. Okay, deploy the code which developers have written. Now, with the help of DevOps, what we are doing, the developer itself is now building the code and deploying the code to the production environment or staging environment. Everything the developer itself is doing, or the operational team earlier, who used to just do deployment. Now the operational team is also doing the development as well. So DevOps is basically an emerging term coined from phrases dev, which stands for development, and ops, which stands for operations. It is a movement that advocates the automation and monitoring of all steps involved in the software development cycle. DevOps is nothing but automation, automating of software development cycle. Okay. So DevOps is a set of practices that automates the process between software development and IT teams, so they can build and release software faster and more quickly. It units agile, continuous delivery, automation, and much more to help development and operational teams to be more efficient, innovate faster, and deliver high businesses and customer. Before DevOps, let us talk about what used to be before DevOps. DevOps is nothing but automation. Before DevOps, let's say there are some developers, and these developers used to write their code in their local machine, and they used to push the code to a remote repository like GitHub. Now ask of developer to write the code and push it to the remote repository like GitHub, GitLab, or Bitbucket. So this was the task of dev team, like writing the code and pushing it to a remote GitHub repository. And the operational team, earlier ops team, what they used to do, they used to pull the code from the GitHub, and they used to deploy it to a dev server. And this was manual. Okay, like once the code was pushed, the developers used to notify the operational team that a new code is pushed to the GitHub repository. Now the operational team used to pull the code to the dev server, deploy it to the dev server. And after the dev server, they used to deploy it to the testing server, where they used to perform manual testing. Okay, where they used to perform manual testing on the code, like functional testing, unit testing, or code analysis. Okay, and after that, they used to deploy it to, if everything is good, then they used to deploy it to a staging server. Okay, where we used to deploy it to a staging server. When everything is in the staging server, and staging server basically manual approval is required. Manual approval, staging. Okay, which is basically a pre-production server. Then we are deploying it to a production server, where the application becomes live. The end user or the clients or customer uses the application. So before, this was the scenario. So there we used to have dev team. Complete task of dev team used to be just writing the code and deploying it to the, or pushing it to the remote repository. Then they used to notify the operational team that new code is available. Then they used to build a code and deploy it to dev server, to testing server, where they used to perform some manual testing. If all good, then they used to deploy it to the staging server, the pre-production server. And when everything is good, then they used to deploy the code to production server. So this used to be a very time-consuming process. Now let's say the operational team have pulled the code and deployed to test server and to the, sorry, dev server and to the test server. Okay, but let's say while doing some testing, like while performing manual testing, there is some errors. Okay, there are some bugs in the code. So then after, they used to generate a report, and that report basically used to be sent to developer, and that there is this error or there is that error in the code. Okay, plus used to be an issue of compatibility. Let's say all the servers are running in Linux operating systems, whereas developers are writing the code in Windows operating system, some are writing in Linux, some are writing in Mac operating system. So as they are running their code in their own environment, so there used to be some operating system incompatibility. In Windows, this guy has written the code in Mac OS. So those code just used to run in those operating system. Those code were not compatible with Linux operating systems, which used to be run in the production environment. So there used to be there used to be code conflict, there used to be operating system conflicts. Okay, plus the developers were less often notified about the errors. Okay, when they used to get notified about the bugs or the errors, then they used to write the code again, update the code again, then send it to here, then notify the operational team, then deploy it to test server, dev server, then to test server, then perform testing, and then if all good, then it goes to pre-production, or it goes back again to developer as a notification. So this used to be very time consuming thing. Okay, it used to take months to get a new version of application available, like version 1, version 2. It used to take months to get a stable version of application available. So with the help of DevOps, but in DevOps, so now when the developers push the code to the remote repository, which is also called CI server. What is CI? CI stands for continuous integration. So once the developer now pushes the code to GitHub repository, a CI server will instantly it will pull the code. It will pull the code and it will deploy it to, let's say, to a testing server or to a dev server or to a testing server instantly. Here no manual work is required. The operational team doesn't have to manually log into the instance and pull the code and deploy it to dev or test environment. Plus this automation server, it will pull the code instantly. Plus it is going to build the code. Plus it is going to perform automation testing. Okay, any testing which can be performed automatically, that this server is going to perform. So first it is going to pull the code instantly, build the code. Build the code, it means, let's say if the code is written in Java, so we build the var files. Okay, with var files or jar files, and then we perform some automation testing. Like you might have heard about a tool called Selenium, through which we can perform automated testing. And once everything is good, now let's say in automation testing something failed, or in build something failed. So this server will automatically, instantly, it will send a notification by email or by, let's say if they are using, their team is using Slack, it will instantly send a notification to them that the build is failure and why the build is failure. Instantly the developer will get a notification, they will work on that, and then they will again pull the code, push the code to GitHub with the new changes. Again it is going to perform those things. If again there is a failure, then it again developers will get notified. Now if it is success, then it will go to a test server. It can be a dev server or it can be a test server. Okay, in test server there can be any manual testing which you have to perform. Okay, there are some right now we have in market, we have automation testing, but there is still need of manual testing. If you want to perform any kind of manual testing, then we need a testing server which will be doing that testing, and then we deploy it to staging environment. And this thing is also automated. Once everything is good, deploy to test a dev and deploy to test environment. This thing is also automated. You don't have to manually go to the servers and perform the pulling the code and deploying the code.
I'm sorry, can you give an example or a scenario why somebody will be using manual testing?
Manual testing. Okay, now let's say you have deployed the code or deployed the application. Now you want to check, uh, let's say you have to check there are some things which cannot be checked using automation testing. Like you might have seen Google CAPTCHA. Okay,
Yes.
this we cannot do testing using
Your voice is cutting off. I don't know if
particular
everybody
application
or
or that
just me.
particular manual testing. Only in that case, let me check. Can you guys hear me? Is it stable? It is stable now?
You're
Yes.
breaking out of.
I see. Okay, is it better now?
Yes,
Yeah.
for me.
Yes.
All right, thank you. Okay, so if the application has like Google CAPTCHA, which cannot be like, which we cannot test using automation testing, so in that case we require manual testing. Only for that section of application we require manual testing. Okay.
Got it.
And after that, And after that, we can deploy it to a staging server. And this is also automated. We don't have to do anything manual. And staging server is a pre-production server. And then from staging server, it gets deployed to. In staging server, basically, there are some manual approval. This is not automated. Earlier also it doesn't need, it was not automated, and now also it is not automated. It requires a manual approval, and after that manual approval, it gets deployed to production environment. So the phase till here is automated. Only the manual testing is okay. Only the manual testing is we have to perform manually. Rest everything is automated. So by implementing DevOps, the software development cycle, like the developers or the application team, is now able to deploy new releases very fast. Okay, earlier it used to take months to deploy a new release of application, like version 1 to version 2. It used to take like months to deploy a new release. But with the help of DevOps, like the developers are getting instantly notification, everything is automated. So it doesn't takes, it takes like 15 days or maybe a month to deploy a new release like version 2. So the software development cycle is much more faster with the help of DevOps. So DevOps is nothing, it is automation. And for automating this process, we have DevOps tools. Okay, earlier we discussed like there was a problem, like the developers used to write the code, let's say in Windows machine and Linux, Mac. Okay, so there was an operating system compatibility issue, like the servers and production they used to run in Linux. So let's say they are running in Windows server. So still there is a compatibility issue. So with the help of a tool called Docker, they can deploy their application in their local machine on a container. Okay, and that container will be of operating system, let's say Linux operating system. So all of these guys will be deploying the container in Linux operating system and building the code in Linux operating system, which basically is used in the production environment. Okay. And for CI server or for our automation server, we have Jenkins. Okay, Jenkins is a very popular open source tool which is used for automation and which is also used to set up a CI server, and through which we can automate the deployment to various phases like to dev, test, staging, and production environment. Okay, so DevOps promises benefits includes increased trust, faster software releases, ability to solve critical issues quickly, and better manage unplanned work. Okay, before DevOps, the software development cycle used to take a lot of time. It was used to be for deploying a new release. It used to take lots of time. Like it used to take months to deploy a new release. And software development process cannot work efficiently without right tools. Similarly, in the case of DevOps, you can always benefit from right set of tools. These tools help in information sharing, process automation, a reduction in deployment times, in continuous deployment, etc. So DevOps is nothing, it is just automation. And in DevOps, we have some tools which helps in automating the workflow in software development cycle. So this is what is DevOps. So it starts from planning, then creating, verifying, packaging, releasing, configuring, and monitoring the application. Everything is included in DevOps. Okay, earlier the developer just used to write the code and push it to the remote repository. That was the task of developer. An operational team task was to deploy to dev server, testing servers, and staging or production servers. But now a DevOps engineer basically takes care of writing the code and deploying the code to the production environment or testing environment or staging environment. Everything is taken care by a DevOps engineer, okay, by a single person. So these are some of the tools which are used in DevOps. All of these tools are automation tools. Okay, some are doing configuration management, some are doing orchestration, some are doing clustering. Okay, like Ansible, Docker, Kubernetes, Chef, Puppet, Terraform, Git, Jenkins, AWS code commit, code build, code deploy, code pipeline. These are all automation tools. Okay, out of which
Gaurav,
Ansible is, yes.
sorry to interrupt. Can you tell us like each one of these tools, what it is used? Like for example, Ansible, where does it play a role in this DevOps?
Okay, Ansible is basically a configuration management tool. Now let's
Okay, thank
say,
you.
yeah, now let's say we have deployed our application in production environment. So we don't deploy a server, like one server in production environment. We deploy multiple servers to achieve high availability. Okay, and these servers will be running behind a load balancer. For high availability, basically in production environment, we have multiple servers. Now let's say there is a new code available, a new software release available, let's say which is version 2. And right now all the servers have version 1 of application. So using a tool such as Ansible, we can install Ansible in one of our server. And what Ansible is going to do, it is going to go to all these servers one by one, and it is going to update the software. Okay, it is going to update the application code to version 2. Okay, any task we can perform. Let's say you want to perform security patches. Security patches on the server. Let's say you want to perform operating system update and new application release. Okay, this thing can be done using Ansible, like security patches, operating system update, and app releases. So if you have multiple servers, let's say you are, this is a very small example of 3 servers. In production environments, we have 10, 20, 30 servers. So now let's say if a new version is available and you have to perform these things, security update, OS update, and app release. So we'll be going to each of these servers, like first log in to this server. If we don't, let's say we are not aware about Ansible. So we'll be logging to each of these server, performing a security patch, OS update, and deploying the new release of application. Then going to second server, doing the same thing, then going to the third server and doing the same thing. If there are 2 or 3 servers, then it is good. But let's say if we have 10, 20, 30 servers, then it's a very time consuming thing. Okay, it might take maybe a day or 2 days to just to update to perform these 3 operations. But using Ansible, it will hardly take 5 or 10 minutes to update maybe 20 or 30 servers. Okay, so Ansible basically takes care of configuration management, through which we can perform security patches, operating system upgrade, new application releases to group of servers which are running in production environment or any environment we are running servers like dev, test, or staging environment.
Thank you, Gaurav.
Okay, so these are all automation tools. Like Ansible is the configuration management tool. Docker is used for deploying containers. Okay, container is something which is a very hot technology this day, which is used to deploy containers, which is basically not containers, which is basically used to ship our application code to a container and which we deploy it to our servers. Then we have Kubernetes, which is a container orchestration tool, which works on top of container, which works on top of Docker, which is used for orchestrating the deployment of containers. And we have Chef, Puppet. These are also configuration management tool, such as similar to Ansible. Then we have Terraform, which is an infrastructure orchestration tool through which we can create infrastructure. Like we deploy infrastructure in cloud environments like AWS, GCP, or Azure. So using this tool Terraform, we can deploy the infrastructure like EC2 instances, like the number of servers we need, the number of database we need, the network infrastructure. Those things we can automate using Terraform. Then we have Git, which is a version control repository. Then we have Jenkins, which basically acts as an automation server. Okay, automation server basically depends upon what we are doing with it. Okay, like we can use it for continuous integration, we can use it for continuous delivery or for continuous deployment. Then we have some inbuilt services by cloud providers like AWS Code Commit, Code Build, Code Deploy, Code Pipeline. Okay, these are also automation services, okay, which will enhance our software development cycle, or automate our software development cycle. Okay, so first we plan, then we code, then we build the application, and then we test the application. Okay, so if you see here in code, planning in code, we have Git, and in build, we have Maven, Gradle, which are basically used to build a Java-based application. Then to perform testing, we have Selenium, JUnit, TestNG, which we use for doing automation testing. Then for integration, we have Jenkins. Okay, we have Jenkins, we have Bamboo, we have TeamCity, which are some of the popular automation servers, automation tools, which are used to integrate in DevOps lifecycle. Then for deployment, we have Puppet, we have Docker, we have Chef, and for operating the infrastructure, for doing the configuration changes, we have Ansible. Then for monitoring the infrastructure, for that we have Splunk, we have Nagios. So these are some of the tools which are used for automating the software development cycle. Okay, so these are some organizations which are using DevOps. So if you see, Netflix is there, Adobe is there, Facebook is there, PayPal is there, Google is there, Sony is there, Microsoft is there, HP is there. All the big giants are using DevOps in their software development cycle. So this is basically a prediction, like based on the market, North American DevOps market size by application. So if you see, it is growing year by year. Okay, so right now we are in 2020. So in 2025, it will be almost double. The adoption of DevOps will be almost double. If the adoption of DevOps will be double, so there will be more job opportunities in DevOps. Okay, there will be more job opportunities, more need in DevOps. Now let us talk about CI/CD. Okay, before talking about CI/CD, do you guys have any doubts or any questions of what we have discussed so far?
Yeah, okay. I mean, I'm okay. Thank you.
All right, now let us talk about CI/CD. Yeah, sorry Tessa, I just saw your message. So what automation tool we can apply? So we can use automation tools like as I discussed, like these are the automation tools which we can use, okay, which will perform automation in our software development cycle. It depends upon our use case, it depends upon our environment, how many servers we have, what kind of infrastructure we are using, whether cloud environment or whether the on-prem environment. So depending on that, we basically use these tools. Okay, now let us talk about CI/CD. This is another thing which is very hot in DevOps. So CI stands for continuous integration and CD stands for continuous delivery and continuous deployment. You can think of it as a process which is similar to software development cycle. So CI/CD is a method to frequently deliver app to customer by introducing automation into the stages of app development. The main concept attributed to CI/CD are continuous integration, continuous delivery, and continuous deployment. CI/CD is a solution to the problem integrating new code can cause for development and operational teams. So CI/CD is basically an approach which allows continuous integration of the code and continuous delivery of the code, continuous delivery to the end users. So this is the flow of CI/CD. So developer writes the code, commits the code to the GitHub or to any remote repository. Then the CI pipeline. Okay, CI pipeline, this thing is basically taken care in, done in the automation server. Like building the code, performing unit testings, integration testings. Okay, all kind of basically automation testing is performed here in CI pipeline. Then if everything is good, then it goes to CD pipeline. Okay, or else if there is a failure, then the developer gets notification of the failure. Then in CD pipeline, we have a review, which is basically a manual testing. And then it goes to production, on staging environment, where basically manual approval is required before sending it to production environment. Then we deploy it to production environment. So everything is automated in CI/CD. Now let us talk about one automation tool, which is Jenkins, which is also called the ultimate CI tool. And it basically is very useful in CI/CD pipelines. So Jenkins' task is to automate the entire process from the time the development team gives us the code and commit it to the time when we get it into the production environment. Our task is to automate the pipeline in order to make the entire software development cycle on the DevOps mode or the automated mode. So for this, we need automation tools. So once the developer pushes the code to the Git, Jenkins will perform some test cases or will build the code. Then it goes to the development server. Then it goes to build. Then it goes to testing server. Then to staging server, and then deploy to production environment. Okay, or some companies also have dev and QA environments. Okay, so some of the DevOps tools we already covered in our webinars, like of Docker and Kubernetes. Do you guys have any questions till here?
Okay. Yes, I have a question. So let's say you're using Jenkins and then Ansible for orchestration. How do you perform a setup? I mean, just an overview.
Sorry, can you come again?
So you just mentioned Jenkins, and then previously you had mentioned Ansible. So where does
They
Jenkins
fit in
fit?
CI/CD pipeline.
Yes, in
Okay, so as the developer pushes the code, then we have automation server, which is Jenkins. And in Jenkins, basically we have jobs which perform some tasks. Okay, those tasks are build, test, deploy. Deploy to dev environment or test environment or staging environment, depending on our use case. So in Jenkins, basically we have jobs. So that job, each of the job basically performs some task, like building the code. Okay, but if it is a Java code, then building the code, testing the code, performing any kind of automation testing, then deploying the code. Now for deployment, it uses Ansible. Okay, it uses two things actually. If you are deploying it to the cloud environment, then you need an orchestration tool. Orchestration tool such as Terraform. And if you are running, and if you want to deploy the code on remote servers, then we need a configuration tool such as Ansible. So once everything is good, Jenkins will run a Terraform script to deploy it, which will deploy some servers, which will be dev, staging, and production server. Or if you already have servers, then what Ansible is going to do, it is going to deploy the code to those servers. Okay, to the dev server, to the staging server. And when everything is good, then also we'll have one job in Jenkins, which will deploy to production environment. Once everything is good, it will deploy to the production environment. So here basically Ansible will do the configuration, deploying the code, applying any software upgrade or operating system upgrade.
Got it. Thank you.
I can give another example. This is Divino. So like in my previous job, what we did was we used Jenkins to instantiate Docker containers. And then
Mhm.
within the Docker container, we actually execute Ansible scripts to provision the Docker container. And then we deploy the packages into that Docker instance. And that basically is kind of like the strategy for unit testing and integration testing.
Yeah, that can also be another a use case. It depends upon what we are using, and it depends upon what kind of application we are deploying. So on basis of that, basically we use some automation tools. Like if you want to run multiple applications on let's say on this server, you want to run multiple applications. For running one application, we need one server. But let's say you want to deploy multiple applications. So in that case, we use Docker, which allows us to run multiple applications on a single server. So using Jenkins, we can deploy and for performing any updates, we'll be using Ansible to performing any configuration update on the containers. Okay, and for orchestrating these containers, we can use Kubernetes. We can use Kubernetes or we can use OpenShift, which are container orchestration tools.
I have a question. From a networking perspective, do you do is the test, dev, staging, are they all like within an internal network, a subnet, or do you have different, if you're going to deploy like in a AWS environment, do you work those in different VPCs?
Yeah, actually it depends upon where you are deploying it. Okay, let's say you are deploying it in cloud environment. So in that case, we have a VPC. In AWS, we have a VPC. And inside that, basically, we have some subnets.
Mm-hmm.
And these are instances are connected to those subnets. Okay, which basically performs networking, the network infrastructure. It depends upon where you are deploying it. You can deploy it on your production, I mean, on your on-prem environment and the cloud environment as well, whether it is AWS or any cloud platform.
Thank you.
Okay, I'm sharing one file on the chat, which is basically the PPT which we used. You can go through that PPT. So we do provide live training on these DevOps tools. Like in the last, I think not last month, I think this month itself, we did one live training on Docker, which was for Docker certification. So we do training in Docker, we do training in Kubernetes, and almost all the tools, DevOps tools, we provide training. So in the next session, I mean, we are going to have another live training this weekend. Not this weekend, it is actually in first week of October, which is on Kubernetes, which is basically a live training which will be of 24 hours. So you can check that with Matt, which is basically the meetup organization. You can contact him by email, or you can go to the website of Coding Bootcamps. There also you will get all the information related to the live training. Okay, if you guys have any doubts or any question, feel free to ask me, and yeah, we can end up here.
Thank you.
Thanks.
Thank you.
Thank you.
Yeah, thank you everyone for joining, and have a great weekend.
Thank you, you too. Bye.
You too. Thanks. Bye. Are you sending this recording?
Yeah, recording will be shared. Actually, Matt will share the recording with you. Yeah, he will share the recording.
Okay, perfect. Thank you.
Yeah, thanks.